Welcome! In this lesson, we will learn what a series is, how partial sums work, and how to decide whether an infinite series converges or diverges. A series is the sum of the terms of a sequence. In other words, a list of numbers becomes a series when we add those numbers together. A series can be finite, meaning it has a last term, or infinite, meaning it goes on forever. The sum of a finite series is always defined, but the sum of an infinite series may or may not be defined. We often use sigma notation to represent a series compactly. The notation sum from k equals m to n of a sub k means we add all terms from a sub m up to a sub n. Now let's define partial sums. The kth partial sum is the sum of the first k terms of the series. We write it as s sub k equals the sum from I equals 1 to k of a sub I. If the series starts at 0, we use I equals 0 to k instead. Example, consider the sequence 1 over 2 to the k, starting at k equals 1. The series is the sum from k equals 1 to infinity of 1 over 2 to the k. Let's compute a few partial sums. The first partial sum is s1 equals 1 half. The second partial sum is s2 equals 1 half plus 1/4, which is 3/4. The third partial sum is s3 equals 1 half plus 1/4 plus 1/8, which is 7/8. Notice the partial sums form their own sequence. Here is a number line showing how the partial sums creep closer and closer to 1. This is the key idea. If the sequence of partial sums converges to a number L, then the series converges, and its sum is L. If the partial sums do not settle on a single number, the series diverges, and the sum does not exist. A very important test is the geometric series test. If we have the sum from k equals 0 to infinity of a times r to the k, then the series converges when the absolute value of r is less than 1, and diverges when the absolute value of r is greater than or equal to 1. If it converges, the sum is over 1 minus r. Example, the sum from k equals 0 to infinity of 1 half to the k is a geometric series with a equals 1, and r equals 1 half. The sum is 1 over 1 minus 1 half, which equals 2. Now, let's look at telescoping series. A telescoping series has terms that cancel when you form partial sums. Consider the sum from n equals 1 to infinity of a sub n minus a sub n plus 1. The nth partial sum becomes a 1 minus a sub n plus 1. For the more general telescoping series, the sum from n equals 1 to infinity of a sub n minus a sub n plus k. The nth partial sum keeps the first k positive terms and the last k negative terms. We can write Sn equals the sum of the first k terms minus the sum of the terms a sub n plus 1 through a sub n plus k. If the sequence a sub n approaches L, then each term in the last sum approaches L. The infinite sum becomes the sum of the first k terms minus k times L. Example, the sum from n equals 1 to infinity of 1 over n minus 1 over n plus 1 is telescoping. The nth partial sum is 1 minus 1 over n plus 1. As n goes to infinity, the sum becomes 1. To summarize, a series is a sum of sequence terms. Partial sums tell us whether an infinite sum converges. Geometric series have a simple test, and telescoping series simplify through cancellation. Great job!